okay, we can deal with the ugly. So I'm going to set these equal to x. So x equals 3, x equals 2 plus a square root of 11, and x equals 2 minus square root of 11. Okay, I'm going to try to get them equal to 0, so I'm going to try to reverse the process. How do I move the 3? Subtract it. Alright, I'm going to start by moving the 2, because I want to get everything on that so I can get rid of that radical. So how do I move the 2? Subtract it. Okay, how do I... Please, baby. Alright, how do I undo the square root of 11? How do I undo the square root? Square it. So now I've got x minus 2 squared equals 11. Okay. Now technically when I square it, remember that if we went the opposite way, what do we normally write out in front? Plus or minus. So when I go to square something like that, if I go backwards, don't I square the plus or minus? So could I have put these two together? I could have, right? So I could have done my plus or minus there, and it's going to get me my 2 answers that I'm looking for. So I don't need to do this one. It's kind of a shortcut, okay? So you're going to actually end up with the exact same answer in the end. All right. What do I need to do? Actually, yeah, what should I do with this 11? Subtract, because it has to be equal to 0 for me to reverse zero product property, okay? In fact, I'm going to rewrite that a little bit different, so don't write that down. I'm going to take the squared off of it, and I'm going to write it like this. Because again, I'm trying to get it so that I can take whatever I have here and multiply it by x minus 3. So what do I need to do with this piece right here? Foil it, good. So what's x times x? Good, what's x times negative 2? And so what would I get in the middle? Because I'm going to have another negative 2x. Negative 4x, what's negative 2 times negative 2? 4. Alright, so we have x squared minus 4x minus what? What's 4 minus 11? 7. Alright, so I'm going to take this and do what with them? Not factor. That's what we're undoing, or it's the factoring. What am I doing with them? We're going to kind of foil, we're multiplying them, right? It's not really foil, but it's close. Alright, I'm going to do my box over here, so it's kind of out of the way of my work. So x minus 3 down the one side, x squared minus 4x minus 7. Alright, what's x times x squared? X cubed. Alright. Let's see. Sydney, what's x times negative 4x? Good. Okay. And Mackenzie, what's negative 7 times x? Good. And Leslie, what's x squared times negative 3? Good. And let's see. Linda, what is negative 3 times negative 4x? Good. And Chris Schwartz, what is negative 7 times negative 3? 21. Good. Alright, so across the diagonals, right, is what I'm looking at now, combining like terms. So x cubed, what's negative 3x squared and negative 4x squared, everybody? God, I need to feed you guys some sugar for breakfast, apparently. Alright, what is 12x and negative 7x, everyone? 5x, and then 21. That's what I'm looking for as my final answer. Alright, I think there's some typos in the next two here. Okay? They did not print well, or we didn't have them done right, or something weird. So there's a 2 and a multiplicity of 2. Okay, so write that down. So add this into the problem. Okay, so what the first thing we do is we set these guys equal to x. How many times am I going to set 0 equal to x? Twice. So x equals 0, x equals 0. How many times am I going to set 2 equal to x? 2 times again. Alright, what do I need to do with these 2's? Subtract them. So we've got x minus 2 equals 0 and x minus 2 equals 0. I don't need to mess with these guys here, right? So we've got this, and this, and this, and this. What are we going to do with the 4 things? Multiply them together. So I'm going to use my function notation. We got x times x, ignore my scribble, times x minus 2 times x minus 2. Alright, I want you to take a minute and on your own multiply together. So I probably multiply my x's. Here's what I would do, okay, to use the least amount of steps. Put these as an x squared, distribute it in, then FOIL. Okay? So everybody try it right now on your paper. Everybody's doing it. Alright, do you agree with me so far? Okay, so I'm going to FOIL, so it's x cubed times x. X to the 4th. X cubed times 2. Negative 2. Negative 2x cubed. Negative x squared times x. Good. And negative 2x squared times negative 2. And I can combine in the middle, right? So x to the 4th minus 4x cubed plus 4x squared. Okay? So, did I get a degree 4 that I was looking for? Yes or no? Yes, right? So they kind of into sketches, we're getting a good idea of what the graph looks like. Okay? Alright, let's look at 17. 4th degree polynomial. So is that even or odd? So I know I've got an even situation going on. So even usually means they both point the same direction. 3 real zeros. Okay, so I'm going to put 3 dots on the graph. 1, 2, 3. Yours don't have to be in the same place as mine. A negative leading coefficient. So even negative, is it going to open up like a cup or down like a frown? Down like a frown, right? So I know both my arrows point downwards. Because on an even they point the same, odd they point opposite. Alright, I'm going to do this. Is that the only one I could have? Probably not. I could probably figure out another one somehow. Let's see. I could go up, come down, bounce up. Technically that works, doesn't it? Yeah. Okay. All kinds of craziness. We could even do a couple of loops in there, couldn't we? Okay. There you go. Alright. So hopefully that's not too bad. That's pretty easy. Alright, last thing. We are supposed to, let's see, we get out 56, right? Let's see if we can get through one of these. So you've got enough to be able to do the homework. Sketch the graph of the function by applying the leading coefficient test, finding the zeros of the polynomial, and plotting sufficient solution points, and drawing a continuous curve through the points. I could calculate my zeros on that, couldn't I? that's where we need to start. So I'm going to set it equal to 0. Okay. What is my greatest common factor? X cubed. Good. So we've got what? 3x minus 4 equals 0. I'm going to do zero product property. Okay. What's the cubed root of x cubed? X, right? So what's the cubed root of 0? What's my multiplicity on that? What was my exponent? 3. So that counts as 3 different zeros, even though I only see one of them on the graph. All right, what am I going to do with that 4 to move it? Add it. Good. And what am I going to do with the 3? Divide it. Okay. So I know at x equals 0, I have 1, 0. So I'm going to draw a dot there. And then I also know I have another 0 at 4/3, which is a little bit more than 1, isn't it? So right there. Let's look at the leading coefficient test. So leading coefficient test says that I need to look at the even or odd. Is it even or odd? Even. Is it positive or negative in front? Positive. So do they both point up or both point down? Up. So I know it's going like this. If I wanted to, could I get a little bit more precise? I don't really know kind of if there's a vertex or something else going on down here. Probably a good number for me to plug in would be here, right? Because I might figure out how low I'm supposed to draw it. I'm not asking you to do a ton of these, but let's see what is happening. So all I'm going to do is pick an x value. What x value did I say we're going to pick? 1. I'm going to plug that into my original function. This is something you've done before. It's not difficult. What's 1 to the 4th? 1 times 3. 3. 1 cubed. Times negative 4. So equals negative 1. So I know I have a point at 1, negative 1. So from there I could sketch. It doesn't have to be perfect. And there might be something else going on in here, but that gets me a little bit closer to a decent curve for that graph. Okay? I'm not going to mess with the second one. Okay? What? No, 7, we're running out of time. Okay? So as long as you've